This is not.
I will search for that. Because about some thoughts and so on, okay? I will record. I will ask no. I will search, okay?
Now.
Okay, guys. My objective today is the following. Or today, yes. Today is finish my sequence. I will finish this problem. Remember this? About the core losses. No, core losses we have talked. About the electric equivalent circuit representation. Why this is important? Because we will have this in DC machines. We will have this in induction machines. And we will have this representation in synchronous machine. So the idea is that how I can represent, what is representing, why the representation in equivalent circuits is valid or not. Okay? So, you have access to the Phoenix. So, you have to know that that guy, that is our movie maker, it is your connection with me. So, if you need something, or you have some questions or something like that, you have several options. First, you can contact what you want to ask for things. You can ask them if I'm crazy or not. Or if, normal questions. So, guys.
Eu só tinha pedido para lembrar de fazer as curvas do Fire Famoso.
Que mandaste tu?
Gostaria de ter lembradas.
Okay, I will do that. Please remember that about the amorphous. Send me an email today. I will put that and on Monday I'll do that. Is the following.
Qual é que é o próximo dos anos? É a continuação?
É o programa, né?
Ah, é a continuação. É a continuação.
Guys, yesterday, and we have seen, and you have seen in the laboratory, that you have in general curves like that gives to you the power losses density. It's about watts per kilogram. You don't need to copy this, huh? And of course your peak. And you have these for 50 and 60 and so on. And we have worked, or we have been working with two materials. One from the laboratory, okay? The other one was M5 and so on, okay? But we have a material that is called amorphous electrical steel. This has been used from many years ago. No? Like that. This material has been used in transformers, right? Transformers with high power. Because the power loss of these materials are very narrow. So I have asked him to remember me to search for this material, these curves, and I will plot these in one graphic in a way that we can see the differences in power losses. If it is 1 to 10, for example, imagine it is 10 watts, the other is 1 watt per kilogram. Okay, you don't need to copy, guys, this. This has been used for high power or large power transformers. Because the mass, again the mass, no? The mass is huge. Remember, if we have tons, the power losses will be huge. Okay? So that's why I have talked with him to remember me about that. Okay? Because it is good to start to see. I think that there are some machines, some parts of the electrical motors, the specialized electrical motors, that can use this amorphous. I will show to you. In certain parts of the electric motor where they know that the power losses are higher. Now, let's talk about power loss. Now, not power loss. Who has some question? Sorry, I'm not using that. É que eu falto. Eu já levei 2 vacinas, está bem?
Tudo bem, também eu.
Não, ele é uma falta de uma coisa de respeito. Isto é a outra. na melhores assim. Who has some questions about the laboratory? I want questions about the report now. Some question. Because the things that I will talk here are connected with laboratory.
So somebody
Deixa eu falar inglês.
about if you make the laboratory this year, the note is the same for.
If you have passed, yes.
Okay.
If you have
somebody.
yes, it is always the same.
Okay.
Guys, you don't have any question about the report. You don't have any question. No question. You sure? No question, guys. Ou lá, isso é a mesma coisa que usar camisinha no saco. Porque não dá para usar debaixo do nariz. I know, it's from Argentina.
Yeah, that's right.
After I will translate to English. Don't have question. You don't have question. Neither, nenhuma. No one. You have question.
I have one, I just don't remember it.
Okay, no problem.
Sometimes
But if you remember, during the class, tell, okay?
Yeah.
Sometimes we have some questions after study. No question? No?
I have one about calculation of the B.
Calculation of the B again, the same.
Yeah, because I didn't understand
Okay, put this question here. Come here. Put this question for all. Transmit this question for them. I want to understand, and it can be the same question in their minds.
Okay, there is a part where we have the same current, always.
Design the magnetic circuit, my friend. Oh, my... Man. You don't need to be a Picasso. And? With air gap or without air gap? With air gap. Minecraft. The other is for you.
What?
Explain to him, more or less, the magnetic circuit, where are the coils, and your question, of course. É difícil, eu sei que é. In English.
My question is about calculating the B.
Where?
Where? In the core.
In the core. What means B? What is B?
It's the density of the magnetic flux.
Okay.
And we have to calculate it for different voltages.
And?
The thing I want to know is if we have to calculate it with using different permeabilities for the different areas of the VH curve, or if we can use always the same permeability, because what we want to know is the influence of the length of the area.
Different voltages? You have different voltages or not?
I think
You have to do. Let me see. Guys, you have one coil here. Okay? And I think this coil has a certain number of turns. So the voltage is applied here, okay? Like that? Okay. So you have an air gap. This air gap can have, of course it's uniform, can have a certain distance, okay? So, you want to know the B here, okay? The first thing you do is what? What is the B? And the magnetic circuit, like that. Okay, let's see. I will explain. Sit here for you. Here, we go. Guys, I will remember you. You have this sign. Don't copy. I'm assuming that is or the first harmonic or something like that, okay? And this is applied in a coil that you have certain number of turns. So, what I want is the following. I know that this relation is universal. Okay? More. Let's do a simplification. Okay? Let's assume first that this drop voltage, not the electrical resistance, remember? This drop voltage is a little bit lower than that. So, to simplify, you have understood that which the voltage imposes the flux, not the current. Remember? That's why you use 230 or 127 or 130 in Argentina like that as a nominal voltage per phase, for example. Okay? Now, don't copy. You know that the flux that is linked, that is embraced by your coil, is your number of turns, okay? And if you see it, and the flux that is passing through the coil, okay? This flux is the Webb's per turn. You see? You say flux per turn. Okay? Don't copy. Follow me. Follow me. So, I want to know this. Why? Because if I know this flux, I know that this flux is your B here. Okay? Times the cross section. Of course, remember, the cross section is that are considering the stacking factor. Yeah? But I think in the laboratory, if you want to do the calculations, consider that stacking factor is 0. Okay? 0? No, 100%. So guys, I want to relate one variable that I know this, and the variation in time of n, the magnetic flux density, and the area. It's okay? Now,
Okay. Why is that?
because the flux that is linked is your number of turns times the flux.
Oh, the flux, okay.
So, in time, I want to know that
Time of
I'm imposing this.
the
This will change in time. It's okay?
Okay.
Now, I will write now one thing in red. Ah, não. Chega para aqui e sentas aqui perto de mim. Não. Chegou atrasado, senta perto de mim. Eu sempre fiz isso.
Se fosse assim, era ali, professor, ainda com canto.
Não. Vou deixar aqui um chapéu daqueles antigamente. Né?
Não, chapéu não.
So, guys, the number of turns is constant. If we don't have any problem, huh? If we don't have any problem. You understood? Hint. If there are some turns that, for example, it is a short circuit, minus 1 turn. Aha! But now we are assuming that all is okay, a normal operation. So, constant, this is constant. So, I have here a relation between a variable that I know, you know, and of course, n cross section, your B. It's okay? Again, if I have this, I can integrate and obtain the B. Et voilà.
So, but why
Why?
you know the current? You want to know the current in
No.
In the what? In the
You want to know what is the value of the magnetic flux density here, the B field.
Okay.
But what I know is I'm imposing the voltage. Okay? So if you know this, you know the amplitude of the B. Okay?
Automatic sound induction.
Induction field
Okay.
or magnetic flux
Field,
density.
field,
Okay?
okay.
No. Come here. Watch. Eu troco. Vai sentar aqui perto de mim. Castigo, anda. Ah, chegou atrasado, não me interessa se tem greve da CP. It's okay? Guys? It's okay? Yes. It's okay? Really? Now, I'm taking advantage of that, and I have to ask about the core losses. Core losses means losses, heat, energy that is lost in the iron, in the core. Okay? Now, we know that there are certain variables about the electric machine. It doesn't matter if it is like that, if it is like that. Imagine you have a circle like that. It doesn't matter if it is a circle like that. Okay? It is a magnetic circle. It's an electric machine. So we have losses. My question is, which variables I have to look for, to verify if I can control the magnitude of these power losses. Control. Okay? Have you understood my question? I will repeat again. You have, well, let me put you an example. You know that selecting the right material, you can see that if for a certain condition of operation, the heat that is lost here is high or no. That's why the manufacturer of the transformers and the electric motors, they select the right material for the conditions that they are working, okay? What means conditions? It depends if it is electric car, it depends if it's a train, it depends if it is a motor in an aircraft, it depends if it is a motor to operate as electric propulsion in aircrafts. Okay? Because these will dictate the following. Joãozinho, come here to your professor. És tu, vem cá. Coitado. I want that. Hey, não fiques nervoso. I want that him, by chance, explain or transmit to us, which variables you have to look to command or have a certain sense, a feel of the power losses in the iron core. Okay? Not me. You have to transmit them. And you have them. You have 5 minutes.
Section, no?
I don't know. Ask him. I'll repeat again. We know, and you have learned in the laboratory and also in the programs, that there are certain variables, electric, mechanical, and even materials, that I have to look for to verify if the power losses dissipated in my machine are higher or not. If the product or the application that you use in that motor will lost a lot of energy and the efficiency will be, imagine, 60%. Okay? All people know today are looking for to decrease the losses. So explain to us, more or less, what you feel, what are in your head. Olha lá, cara.
Obrigado. E foi em Zoom.
In English.
Just in the iron core or the whole?
Now I prefer the iron core. The other ones you will see.
Okay, so the first thing, I think it's the cross-section area or the
No,
area.
don't look for me.
Okay, sure.
Use the board.
Sure.
Put the formulas. Use, guys. If you put a paper and you put, if you want to help him, discuss with them. I like this in 5 minutes. No, don't look for me. Look for her.
Okay, sure.
They are your judges.
Okay, sure. So, just by following this formula that teacher has written here, you can see that
the highest or the longest way.
Yeah.
Yeah, he knows that.
No,
Help him, guys.
Parasexual.
I think you have to just look at the hysteresis losses that you have
Where?
and
Where?
in the core.
Come here. Draw the magnetization curve here and show to us. But this is related. No. Come here. Show to us the magnetic material. Come here. Yes, my friend. Ajoelhou, tem que cruzar. Conhece essa? Se ajoelhou, vai ter que cruzar. Vem cá. Ah, coitado, já não tem lugar. Lá? Guys! Guys! You have blood or beer in your body?
No, water.
Okay,
So,
tell to them.
yeah. Well, the first thing that we have to look, or I will look, it's the hysteresis losses, because when we come to the saturation point, then we will have a lot of we will have a lot of losses, which is due to the harmonics.
Aham!
Harmonics, current harmonics.
Levanta e explica isso que eu te expliquei ontem. Anda. Pensas que eu não ia outra coisa?
And then,
Yesterday I have explained all things to this guy. So compliment this to him. Come here. Go there and help the two.
Isso é muito violência.
Não, é assim mesmo. É divertido.
Estou a brincar.
Guys, you have to construct the model. Don't look for the formulas. Esquece as formulas. Diz mesmo. Não tens vergonha. Tu também, Daniela. Guys, look for. Help him. Help them. Talk. Pedro, talk to them. Oh, man. Pedro.
So in this graph you can see the power losses in the core depends the B and the frequency.
And the sun is cold. Okay. And let me put one question. You have to be trained. Guys, you have two things or three things. One is the material. Okay? This comes from the material. This comes from the material. The manufacturer gives to you. If it is a good electrical steel,
Yes.
but, or is a cheap electrical steel. That in the laboratory, Sarah, that in the laboratory is not cheap. It is cheap. You have seen that the hysteresis is huge sometimes. Have you seen that? I cannot see your face, so I don't know if you are agree or not. I only see the eyes. So, the material. We are agree with the material.
But
No.
If the lamination was in the way and all the
Draw here.
No.
Draw. Because you have a draw in your head. But you don't have any movie that can transmit to the girls that wants to know about the electric
No.
machines.
I think this. If you have all the lamination with this way, when the iron is made,
What do you mean lamination this way? Like that?
yes, like that.
So
yes.
draw.
Yes, it's the way. It's always
Okay.
the lamination. If you have all the electric
Help him.
When they pass in here, it's more difficult. No, in this I don't think I'm explaining.
No.
you mean the flux, which is
Yes, the flux, because you have the option. It's an EI. When you put all together, you have the in this. When the
Fala em português que eu procuro.
See, no.
transmitir para eles.
When the manufacturer make this, it's low expensive and make all the lamination on the same way. When you cut, this is a piece. This is only a unique piece, no?
Se vê que ele vai ver? Não, também não. Guys, I think that he's talking about the following. Não fiques nervoso, cara. Pode tirar, não fiques nervoso. Não fiques. If you cut the lamination, remember, I'm putting this like that. You have the laminations here. So your magnetic flux, in reality, is doing like that. It's okay? You see that your machine is a 2D. It's okay? But you have this in the problem that I have with you. But if you have the flux coming here, in this direction, is cutting here. So you have a lot of varnish here. So the magnetic reluctances are here. Is bad. You see? No? It is good, no problem. That's why I tell you, there is I put this in 3D, okay? This is one lamination, okay? You have the vanish, and you have another lamination here, and a sandwich. So, the machine is made and cut, like your colleague has told, to the flux coming from here. Coming or walking, okay? In this direction, to the... If we put the flux in the wrong way, what you see here? You see still air. Still air. It is air from the magnetic point of view, because you have vanish. Et voilà. See? Talk in English.
When exists the lamination, the manufacturer cut in here,
Yeah.
and this are this, and this E are this. And when lamination all the way is in here, when the cross in here, it's more difficult. I
know, I want to do. It's telling that if this is too narrow, the flux here will be higher. It's okay? I'm sorry. The flux is the same, but the cross section decreased. So the B will increase. So you can see in the fan simulation, in that simulation that the Professor of France has told a very good podcast for you, that there are parts here that start to saturate. Here, if you decrease this for the half, and you see that this starts to saturate. Saturate means that you are going to this. And see, please. Claro! If levanta, sabe sim, vem cá. We are talking about when it goes to saturation, and you have a question about that. What happens when your operation is going to saturation out and in, out. Out here is in. So, my friend, one sentence, one affirmation, one sentence is like, if the machine enters in saturation, magnetic saturation, and we don't want this. We don't, because we see that the power losses increase in every electric machine. It is a nightmare. Heat is the nightmare of any instrument, any device, including the electrical machines. Heat is the problem, only. So, when it saturates, yesterday, he went a meeting with me, and he asked me, Professor, I have a question. To be honest with you, I have a question. It is telling me to explain what happens with the power losses when it's in saturation. This is one of the questions that you have seen, even in the problems. Now, he will explain to you this. If you don't understand, guys, it's your colleague. You help, you question. I want this between the groups and with you. So, it's very shiny. has to lose his shine. If he doesn't know, it doesn't matter. If he doesn't know the correct word, he can tell the same thing in another way. It's okay, that's why I won. Eu pensava que ia safar.
So, pode ser em português?
No, I'm sorry. Slowly, if you have some difficulty, we have a lot of online dictionaries in English. A lot of. Not for me, for them.
Certo, mas é para explicar porque é que as perdas por isto trazem.
Não, as perdas na saturação.
Ok.
Okay? Vá, explain to them. Draw if you want. 3 minutes.
The losses in
Talk loud.
the main losses that are net is the hysteresis losses.
Manel, talk loud for them. Okay? For them. Don't be afraid. For them, yes. Camaradas. Like that.
So, if we entering in this area, this zone of separation,
Não sei quando. E tu também, Odinhos.
we will increase this magnetic
Divide the magnetization curve in 2 parts. One, the linear part. The other, the non-linear part. Start explaining the linear part. That is not easy for us. That's why I told to you, do all things in the report in the linear part. Okay?
in the linear part,
Estás ferrado, vais ter que fazer essa experiência.
for example, this
Sozinho.
point, we have
Não vais não.
area of
Não vais fazer.
hysteresis, which is
One thing, Manel, when you talk for them, don't give the make as much.
don't show your back.
Don't show your okay? Talk like that. Talk.
Estavas a
Ok.
dizer
É, filho, mas não pode. Entendeu? Levas um tiro aí nas costas. Bum! Vá. Talk with them. Ah, meu filho, tu também vais entrar na relação um dia desses.
we have lower value of magnetic
Guys, help him.
flux density.
Sarah, help him, please. Sarah, help. Now the girls only. Sarah and Daniel. Help him. If you have a magnetization resonance, it means that you have a certain B there. Of course, it's not 0. Okay? Daniela, help him. And Sarah also. He will like too much. Eu tenho que ajudar o Manel, senão ele vai desmaiar.
Sim, sim.
Manel, eu tenho que ajudar o senhor vai desmaiar. Só para ver. Manel, come here. My friend, sit here. Sit with me. My objective is that you learn and they also. And you have no shine. Because in a company, there you have to explain to the bosses and so on. Okay? Don't be shy, my friend. The English, it will out. Let me resume this to not have too much time in this because they start to be nervous. Guys, you know that the peak of the bee is a variable. Why? The peak of the bee tells to you the limits when you are operating. If you put 20 or 50 volts, remember in the laboratory, you go to here and you operate, in the marvels and linear load that I called Barbie's load. It's like that. Okay? Sarah? In the laboratory, I don't know if you remember, the voltage is not alternate sinusoidal. Remember, the voltage was more or less like that. It seems a triangle or something like that. So, when you are operating, no lower, even in the linear region, you have to think two things. No, you have to pay attention to things. One, I'm in the linear region, and if the voltage, the excitation, has not too much harmonics. Where the harmonics come from?
Alternating current. The harmonics from alternating current.
No? The harmonics appears in the voltage, for example. Give me some examples where the signal that you put here has a lot of harmonics. I'll give you one example. The sun is radiation of the sun that comes from the harmonics. Power converters. Tu tivesses,
Magnetólogo.
não? Conversores.
Já tive uma cadeira, não tive aqui, mostrei aqui, mas tive algumas partes.
The idea is the following. In general, the voltage that you put here or that you have here, it's not a sinusoid. You have a lot of noise and a lot of devices that reduce the power quality. You remember this buzzword? Power quality. So, in the laboratory, it has harmonics. So, not only the BP, but the frequency content that you have in your voltage. This is a math for power converters. So in the laboratory you have seen that. This is, I think it is 1, 5, and the other was 1, 3, 5, 7, and so on. Harmonics. So the frequency, my friend, is 3 times 50, 5 times 50, and so on. I have explained this to some of you. I have explained. They have this explanation, and also you. Guys, if you have questions, go to your colleagues. Go to the rest of the team. It's like that. Okay, Sarah, Daniela, you can help each other. I'm doing this again because there, in the real world, you have to work with different persons, with different teams. Okay? And not sleep when the boss is in a meeting.
Tenho uma criança de 5, 15 dias, professor.
Puta merda. He has a newborn. So he has to wake from 2 hours to hours to put the fingers. Oh, my friend.
Eu vou tentar, professor, manter uma contato.
So you will be a zombie during 3 years. I was there.
No, I have 1.5 years.
Oh, yeah? Okay.
Yes, it's
Oh, 5 with a newborn. Oh, very good combination. Yes, my friend. Don't worry.
It's a COVID.
Don't worry. I know.
I use one.
Yeah, I know. The TV was all the same series. So, guys, now I will begin. Is asking if we can go from the yeah, I know that. This is Castillo. No, claro que vocês escreveram. He's very shy, guys. He's very shy. But he knows about that. I know that he knows. But sometimes we know. And there are some words that it doesn't go out of our mouth like that. So we have a drawing. You put a drawing. Okay, now I will put you to relaxing. Okay? And you will do the thing that you most love in the university. That is copy. Don't worry. Falta o quê? Diz? Não falta.
Pois, né?
Não, relaxa, tá? Relaxa. I will finish this problem because the last end, don't open the mouth. Because when you open the mouth, there are a lot of air that comes down. And after some years, maybe you are waiting for a 3 month pause. the representation in electrical. This part is a little bit tricky, but I will put this slowly. Okay? You have in this text that we will replace sometime. You have to explain in detail for this example that I will solve here also. You have here explained it. I will explain here the same, but for this magnet, the steps are the same. Okay? Eu não leio isto. Of course. Guys, this is for your help. When you go make some poopy or something like that in the bathroom, when you put your children swimming, okay, go there. Because I have done this step by step, explain point by point, like a mother. It's like that. Different for the books. Okay? I tried that, yes. So let's put here. So we are talking about, you have this? Yeah. We are talking about the last item that I will take here the advantage to write for you. I will after give to you this even in scan, okay? Because there are some times that I put here that are not here. Or I put a resume here, okay? I have to do that. Eu conto tudo, meu filho. Ponha. There was, guys, you have to explain them what this means. Ponha. Remember that? No? São muito novinhos, coitadinhos. Uns bebês. Estás cansado? Eu sei. Sexta-feira não é fácil. Eu sei que não é, gente. Friday is a little bit tricky. I know that. I know. But let's learn and at same thing at same time be fun. If not, we start to sleep. Me also. Problem 1. You know, continuation. Item A, yeah, because it is equal for every person. This item talks about the equivalent circuit of the magnetic circuit. I think that I will divide this, and I will divide this. So, if you want, you follow me, but if you see something here that you don't understand, or you don't remember, ask me. Don't be shy, my friend. Never. Ok? Vais acabar fazendo teste comigo e vais tirar para a minha equipa. Vais ver. Eu também, para não ficar com os ciúmes. Ele limpa as rodas e tu limpas o capô, tá bem? Guys. Let me. I will draw here. Fala alto. It's okay, guys. The person that I usually more careful is the persons that are not Portuguese, because it is not an obligation. It's that sometimes my English is so bad. Sometimes my English is so good. Sometimes I don't know in general the background. That's why I have to be more careful. Os estudantes portugueses é que estudaram aqui estão ferrados. Because the Portuguese students, I know the background, you know? So, this is the magnetic circuit that we are studying this problem. It is a single phase transformer, okay, where you have here called primary, and you have here the secondary. Okay? And we have here an iron core, laminated, and electrical steel. Don't copy, guys. Take a photo. Why? Take a photo. I will draw now a second magnetic circuit. This magnetic circuit, I know. What's wrong with that? Nothing. One coil, second coil. The magnetic flux comes here. Don't copy. Follow me, guys. Follow me. This is symmetric, okay? And this 3D, of course, and laminate, blah, 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 blah. The same. I will draw another one. Já vai embora? Não pode ser, né? This is more equal to that, but has a gap, okay? Gap. And another one. Iron. Of course, it's not pure iron. Iron is called electrical steel lamination. Okay. A coil here. Another one. Yeah. Let's put like that. Is general one. Okay. After the person can select the direction. Iron. This can rotate. This can rotate. Okay. With a certain speed or a position somewhere. You have here three different magnetic circuits. Three different. In general, this comes from transformer or some application that wants to put some high magnetic field in their gap. Like, for example, people that study materials, they put the material here. Okay. You have here, it is called in general, this is a switch reluctance machine, and I will draw after the induction machine and so on. There are some properties that are common. The properties like that. The material in general, more or less the same. More or less a set of the materials that are known in the market. Okay. And all these magnetic circuits now don't copy. Don't copy, guys. This is difficult, huh? Don't copy. All these devices, all these electric machines, remember, this is a non-rotating electric machine. In general, they put electric machines. They can put rotating electric machines. Rotating electric machines is that usual back then, okay? In general, people from our wonderful ADP utility is about the utility that distribute the things. In general, when they interview the students, they ask a question that is a trick. It's like they ask, give me an example of a static electric machine. A transformer is a static. Static means that it not rotates. This is an old term. It is not used. Okay? The guy is playing with you. And you answer. This is a transformer and fuck off. Yes? In general, they do that. I don't know if in your country they do. Sometimes they put this question only to see if you know something. But this is, there's no value. Okay? So, all these electric machines, don't copy, have an electrical port where the energy can be in, out, in, out, in, out. It's okay? Now, we have common in all these. We have a power source. Que coisa horrível. Let me only pick one, okay? After we give the 10 minutes for them. Let me only to finish this part. Okay. I will use the green. Lagarto. And this is a power source. Power. Don't copy. You don't need to copy this. Power. You will see why I'm putting this. O Amorino está aqui. Okay. From the point of view that he is a power, he does no eyes. He doesn't know which type of magnetic circuit, which type of device is from this to here, this to here, this to here, and then the same here, this to here. I repeat again. We have here two frameworks. One is the magnetic, and this is the electric. Okay? So the power source sees something here, feels something here. Okay? And it puts here or not power, active and reactive, power and so on. So, in general, when you want to construct a model to make calculations, today, you can do this, you can put this in a finite element program. Today is possible. And you can simulate an electric circuit here, like for example, a power source, a voltage power source with a certain resistance and blah, blah, blah. Okay? These are concentrated elements, okay? Concentrated, represented by L and L, okay? And you can connect for another reality that is magnetic circuit. Why I need to represent these by electric equivalent sequence? Because if I have all my system represented as an electric equivalent circuit, it's more easy to simulate. You can see this, for example, in the power grid. Thousands and thousands and nodes and so on and so on. Now, no questions, guys. Okay, 10 minutes, and we continue the movie. Casa de banho, Kiki.
Até